Good morning, student. Today we are going to study chapter number 5th, which is nothing but a refraction through lens. Okay, refraction through lens. Refraction through the lens. What is a lens? Lens is a refracting medium. Okay, lens is a transparent refracting medium. Refracting medium bounded by either two spherical surfaces or one spherical other plane surface. Okay, so this is nothing but a lens. So here what we are going to do, we are going to study about types of lenses. There are two types of lenses. First one is convex lens and second one is concave lens. Concave lens. This convex lens acts as converging lens. Converging. Here you find that all the rays which are coming meets after refraction into a single point, and concave lens acts as a diverging lens. Rays are going out from a same source. Okay, is nothing but diverging. Here ray get diverted after the refraction, and in convex the rays get converges or meet into a single point after the refraction. So two types of lenses are there, convex and concave. Convex lenses are made by a two spherical surface, while concave lens is like this. Okay, so these are the two types of lenses. Now this convex lens is again categorized into the three different types. First is biconvex, second is plano-convex, and third one is concave-convex. Okay, biconvex, plano-convex and concave-convex. Biconvex means both sides the convexing surface. Plano-convex, one side plane, other is bulgy, and concave means both are the bulgy sides, like this. Similarly, concave lens get categorized into the three different categories. First one is biconcave, both sides are concave over here. Second lens is plano-concave. Plano-concave means one side plane, another is concave, and third one is convexo-concave. Convexo-concave, right? So that is like this. Both the sides are concave over here, like this. Okay, so these are the different types of lenses. Actually major category is convex and concave. Convex acts as converging lens and concave acts as a diverging lens. Concave categorized into three. biconvex, then plano-convex, concave-convex, while concave lens categorized into three: biconcave, plano-concave and convexo-concave. Right? Now we are going to study about action of the lens as a set of prism. Action of the lens as a set of prisms. So this first is convex lens. If I cut this convex lens into three different sections, then we find that the first section and the third section, first, second and third, if I say, the first section and third section acts as a prism. It acts as a prism, while second section acts as a rectangular glass slab. Same over here into the concave lens. When the concave lens is divided into three sections, then we find that this first and third acts as a prism. Okay, this is a base and this is nothing but a top of the prism. Okay, this is same way over here, and the middle part means which is second one acts as a rectangular glass slab. Okay, so we know that in the prism, when a ray of light passes through the prism, then it converges to the focus. Similarly over here, converges to the focus, right? And a ray which is going through a parallel line glass slab along the normal, then it goes undeviated. Similarly over here, we know that a ray of light falling on the prism turns toward the base, so it diverges. Here also it diverges. Okay, and when the ray of light falls along the normal on the glass slab, then it is undeviated. So we find here both of the actions. Convex lens acts as converging, or concave lens acts as a diverging lens, right? So this is whole about converging action of a convex lens and diverging action of the concave lens. Convex lens divided into three parts. So first and third part acts as a prism. In case of the prism, when the ray of light fall on its surface, then it tends or bends the ray of light after refraction toward the base. So toward the base it is shown, and a parallel glass. Okay, when a parallel glass slab, a ray of light fall along the normal, then it is undeviated. Over here, same. Here toward the base, here also toward the base, which shows us that convex lens as a converging, and here we find a diverging action of the lens, diverging. Okay, so this you have to keep in mind. Next, we are going to study about technical terms. What are the technical terms related to this lens? Okay, let's see. Okay, now first term is center of curvature. Center of curvature. Actually, the lens is made, okay, when the two spherical mirrors are taken and two spherical lenses are taken and they are overlapped on each other. Then the central part, this part acts as what? A convex lens, right? Say this as a center of the sphere. This is second center of the sphere. Okay. So what is center of curvature? It is a center of a spherical surfaces whose part is a lens. Okay, it is a center of the spherical surfaces whose part is a lens. Second definition is radius of curvature, and here you find this is about convex. So similarly about the concave, we can show the diagram. Two spherical surfaces, and this part acts as a concave lens, and the center C1 and C2. This is the center of curvature. Okay, so in the both lenses we can show like this, a center of curvature. Second, center of radius of curvature. Radius of curvature. What is radius of curvature? It is a radius. Radius means from this. Okay, so we can say it is a radius of spherical surfaces. Whose part is a lens? Whose part is a lens? In same way, here also we can show this one is the radius of curvature, which is denoted by capital R. Okay. Next is principal axis. Third one is principal axis. What is principal axis? Principal axis means it is a imaginary line which passes through center of curvature and O. Okay, तो यहां से जाने वाली जो इमेजिनरी लाइन रहेगी उसको ही हम कहेंगे प्रिंसिपल एक्सिस. So this is nothing but a principal axis. Okay, this is our next concept, principal axis. It is shown by a line which is passing through. Actually it is imaginary. This line is not present there, but it is an imaginary line which passes through the center of curvature, right? Next is optical center. Optical center. It is a point on principal axis or point of intersection, I say. Point of intersection of principal axis and principal section. So I can show here in case of convex, this is a principal section and this is the principal axis. This point of intersection is nothing but optical center, which is denoted by O. Here again say concave, principal section, principal axis, point of intersection, acts as optical center. Okay. Next concept. The thing is that over here, if the ray of light is passing through the optical center, then it is undeviated, directly incident. Okay. When the ray of light, incident ray, passes through optical center, then it is undeviated. Next concept is principal foci. Okay, principal foci. Actually, this word is given because there are two focus point, right? So foci is given. Okay. Now, first focal point for the convex lens. Convex lens. First focal point. What is first focal point? It is a point on principal axis of lens such that ray of light ray of light coming from it, ray of light coming from it after refraction, become parallel to principal axis. Principal axis means, say this is a convex lens, principal axis and principal section. A ray of light coming from this point, okay, this is the point which is known as first focal point, F1. A ray of light coming from this point after refraction is parallel to the principal axis. Okay. Similarly, in case of concave, we can show that it is a point on the principal axis. It is a point on the principal axis It is a point on the principal axis of the lens such that ray of light seems to, ray of light, here only you have to add the word seems to, okay, for concave, okay, seems to coming from it after refraction parallel to principal axis. After refraction it is parallel to principal axis. Okay, these are the both definition for the first focal point. Next is second focal point. Second focal point. What is second focal point? It is a point on principal axis. Point on principal axis of lens such that the ray of light incident parallel to principal axis after refraction passes through it. Okay, यानी यहाँ पर जो भी कोई रे ऑफ लाइट पैरेलल इंसिडेंट होगा आफ्टर refraction it passes through a point. That is nothing but a second focal point. This is actually the first focal point, right? In case of convex, we can show that a ray of light incident parallelly on this lens and it seems to pass through the point. Okay, so we can write for concave also. It is a point on the principal axis of the lens such that the ray of light incident parallel to principal axis after refraction seems to passes through it, right? This is for only this one we are writing this definition for concave lens. Okay, so these are the concept. Now last concept is focal plane. Let's see the focal plane. Again here two focal planes are there, first focal plane and second focal plane. Okay, let's say focal plane. It is a plane passing through first focal point and optical center. Okay, optical center. So here I draw the picture. Here optical center, here the first focal point, here the second focal point, and the plane which is passing through this first focal point and optical center is known as first focal plane. This is first focal plane. Now what is second focal plane? Second focal plane is nothing but a plane passing through second focal point and optical center So here same way I will show you this one section, this one axis. This is first focal point and this is second focal point. So the plane passing through second focal point and optical center, that is known as second focal plane. Okay. Now some notes that we have to keep in mind are: first, if the medium on the both side of the lens, ये लेंस है, लेंस के इधर एक मीडियम है, इधर एक मीडियम है, दो मीडियम है. If the medium of the both side of the lens is same, then the first and the second focal lengths are same. Then f1 is equal to f2. If m1 is equal to m2, means medium 1 is equal to medium 2, then we can say the focal length of first or focal length of second, both are same. This is the first point to summarize. Second, we say the focus, we mean that second focal point. कभी भी focus का जिक्र अगर होता है तो second focal point consider करना है. Second focal point we are taking in consideration. Next one, convex lens, if it has a real focus. Convex lens को होता है real focus. Okay, this is third one. And for concave, this is for what? Convex. And for convex it is virtual focus, that is for concave. Okay, so this is the third point to be noted. Fourth one, if a beam of light falls obliquely parallel to the principal axis, means like this, parallel to the principal axis, okay, then we find after refraction they meet into a single point which is on the perpendicular drawn from the focus. So this is a fourth one. Next, focal length of lens depends on some factors. F depends on two factors. So first factor is the refractive index of material of lens relative to surrounding medium. Okay, refractive index. How this refractive index affects this focal point or focal length? So if a lens is placed, in water, instead of air, its focal length increases. We know that the refractive index of water is different from the refractive index of glass, so this happens. Second one, radii of curvature. Radii of curvature of the two surfaces of lens. Radii of curvature. Radii of curvature is the second factor which affects the focal length. Okay, a thick lens have a less focal length, while thin lens have a more focal length. More focal length. If part of the lens is covered, then there is no change in focal length. So that point you would keep in mind. Okay. So next topic related to this chapter we will see in the next video. Thank you.